Lesson 3.2 is sampling techniques. So sampling techniques are used when you want to create information about a large group or population. So you collect data from a sample or a smaller group of that population that you can extrapolate that data from. So I would pause the video and write down these notes first. So the first vocab word is population. Population is your entire group that you're collecting data from. So for example, all the students at your high school, or all the high school students in the entire United States. Is this big group. A sample would be, I'm going to collect data from a smaller group from that population and then use that data to make conjectures about the larger population. So for example, if you're talking about your entire high school, a sample would be a group, maybe 100, 200 of those students that you then take that information and extrapolate. So there's different ways that we can collect these samples. One of them is random sampling or simple random sampling. So random sampling means that every member in your population has equal likely or equal probability to be chosen for your sample. Simple random sampling would be something like if you're talking about your high school, you assign every student at your high school a number and you use a random number generator to pick the 100 students you're going to collect data from. Systematic sampling is still random, and you pick, so again, you number all the students in your high school, you pick a random starting point. I'm going to start at number 7, and then I'm going to pick every 15th student from there. And that would be a systematic sample. You created a system to collect your random sample. Convenience sampling is not random. So that would be like if you're collecting data for your entire high school and you just ask people in your classes. You select people who are easy to reach, easy to talk to. And since it's not random, it could be biased. So that's the next vocab word, bias sampling, one that's not random. Having a biased sample could affect your outcome. If you're only talking to people in your classes, then that's a certain group that may have similar attributes than the entire population. This first example, a researcher collected IQs of 200 people, and the mean of those 200 IQs was 99.74. So 3 different researchers are taking a sample and trying to find the mean of the population based on the sample. So A through C are different ways that researchers collected samples from this population. So I want you to comment on each sample. Are they biased or are they unbiased? And any advantages or disadvantages they may have. And then part D, which of these methods gives the best approximation of the mean? So for part A, a sample is taken by taking the first 20 numbers and the last 20 numbers, and when written in order, and then the mean they found was 104. So this is not random. It's a really easy way to collect a sample, but it's not random. You're looking at the lowest 20 and the highest 20, but it doesn't necessarily give you a good view of the entire population. So if you haven't already done so, go ahead and pause the video and do B through D. So for B, a sample of every 5th IQ was taken. They found the mean to be 98.725. This is the systematic sampling. It's random and unbiased, and it's pretty easy. You just have to start your starting point, go through, and it ended up being a very accurate representation of the overall mean of the population. A random sample of 30 IQs, this is just your simple random sample, use a number generator or something. It's also random and unbiased, so it's a pretty good way to collect data, but it's very time consuming. You have to go through, pick a different number every single time. If you repeat the number, you have to be careful, but it's truly random. So then which of these gave the best method, which was the best approximation of the mean? The systematic one ended up being the best representation. So these are different ways that you can collect data to represent your overall population without having to collect data on the entire group. Here are a couple more sampling definitions. I would pause the video and write these down before I talk about them. So the first one is quota sampling. That's setting certain quotas for your sample. For example, 8 boys and 8 girls. Usually it can be pretty inexpensive and easy to perform, saves time. If you need to go out and collect data for 40 people, you say, okay, I want 20 girls and 20 boys. Cons, usually not random, usually kind of convenient sampling. It could therefore be biased and unreliable. Similar but better is stratified sampling. So you divide the population up based on shared characteristics. So for example, if you want to collect data from your entire high school, and a percentage of your high school is 9th graders, 10th graders, 11th graders, 12th graders, then you take that same exact percentage and you want of your sample that same percentage to match with that group. So for example, if you have 20% of your school is in grade 7, then 20% of your sample should be from grade 7. To make sure this is unreliable, that 20% you pick from grade 7 needs to be a random sample and not just, 20% the 7th graders that I know. So here's an example. Mandy asked that all students in her school take a memory test. They have to remember as many objects as they can from the 20 that she shows them. And this table shows you how many students are in each grade out of her 150 students at her school. So this is her population, and now she wants to take a stratified sample of 40 students from this population. So remember, stratified sampling is whatever percentage you have in the overall population, then your sample should have that same percentage of people. So we want to show that her sample of 40 students should have 5 students from class 7 or grade 7. So go ahead and pause the video and show that of these 150 students, she needs to select 5 students from class 7 for her sample. So class 7 or grade 7 has 20 students out of the 150 total students in the population. So that means 20 out of 150, that's our ratio that we want to use for our stratified sample. And then we want to have a total of 40 students in our sample. So 20 out of 150 or 2 out of 15 of those 40, and that ends up being 5 1/3. You can't have 1/3 of a 7th grader, so therefore 5 students in the overall group should be from grade 7. So now go ahead and pause the video and do the same thing. Figure out how many students should be from the other 5 grades. Okay, part B, determine how many students Mandy wants to select from each of the other classes. So for grade 8, she has 27 out of 150 students times her sample size of 40, so she needs 7 students from grade 8. Grade 9, 23 out of 150 for the whole population times 40 for the sample, so 6 from grade 9. Grade 10, 26 out of 150 times 40, so 7 students from grade 10. Grade 11, 30 out of 150 times 40, so 8 students from grade 11. And then lastly, grade 12, 24 out of 150 times 40, and that's 6 students. If you actually add up all of 6 of these numbers, it only adds up to 39 instead of 40. That's okay. That's going to happen sometimes in stratified sampling, just based on the way we have to round. It's not going to be perfect. So this has been stratified sampling. So again, if you want to take a certain percentage of each group to better represent your entire population. Sampling techniques, you're going to be using these if you collect data for any kinds of research projects or internal assessments, anything like that. So this has been sampling techniques.